chemistry doubt session. Any doubts you can ask me now. Meanwhile, I'll just go through some questions. What I was explaining in class today. Yes, this is a wonderful way to recall. So, first I was explaining about P-block elements. Vallabh, good evening, beta. So, what I was explaining in the morning in the college. I work for Trividya Junior College. This is in Hyderabad, AS Road branch. I'm a senior chemistry faculty. This is what my students know. So today's topic was group 17 elements. Actually, we don't know whether group 17 is going to be present in our syllabus or not. Give me 1 minute. Group 17 elements may not present in our coming up examinations. Reason is, it is not there at present in NCRT books. What I was explaining them to. Group 17 introduction part and all. So I try to remember all the parts. Group 17 P-block elements: fluorine, chlorine, bromine, iodine, and acetylene. Meanwhile, if anyone comes and asks me a doubt, I will explain that. Okay. Fluorine is called superhalogen. Okay, superhalogen means very strong and reacting always with almost all the elements. So that's why it's called superhalogen. Why they are called halogens? Halous means seawater generated salts. That means most of these are chlorine, bromine, iodine. All these are available in the form of salts and they are taken from the seawater. That's why. In seawater, sodium chloride is present up to 2.5%. 2.5%. Good evening, Amma. Good evening. Give me 1 minute time. I just close one more window. Some dog barking sound is coming. Give me exactly 1 minute. Fine. Sorry. So what I was talking is, what I was saying is, sodium chloride is present up to 2.5% by mass in seawater. Then coming to the fluorine atomic number is 9, chlorine 17, bromine 35, iodine is 53, acetylene is 85. Electronic configurations: fluorine, helium 2s2 2p5, chlorine, neon 3s2 3p5. Then if you take all these elements, it will be like ns2np5. So ns2np5 is the general electronic configuration: fluorine, chlorine, bromine, iodine, acetylene. For fluorine it is 2s2 2p5. For chlorine it is neon 3s2 3p5. For bromine it is argon 3d10 4s2 4p5. Then any doubts you can ask me, right? Fluorine, chlorine, bromine, iodine is 53, so it will be like iodine. What we are discussing, electronic configuration, the same thing: ns2np5, ns2np5, ns2np5. But the thing is, in acetylene case there will be 4 F electrons, and in case of bromine and iodine there will be 3d10 and 4d10 electronic configuration. F configuration you can notice in case of acetylene. Then fluorine. Fluorine is yellow colored gas. When it comes to chlorine, it is greenish yellow gas. Bromine, reddish brown liquid, non-metal liquid. Iodine is violet color sublimable solid. Acetylene is radioactive metal, so metallic element type nature. Okay, now because it is radioactive, more size is there, so having that type of tendency. And we don't discuss much properties of fluorine, chlorine, bromine, and iodine only. As usual, coming back to the topic. Atomic radius down the group increases, ionic radius increases, density increases, melting points increases, boiling points increases, ionization potential decreases, electronegativity decreases. Fluorine is the most electronegative element with a 4.0 value. Coming to electron affinity is very special. Electron affinity of chlorine is more than fluorine, then bromine, then iodine. Bond dissociation energy: chlorine, bromine, fluorine, then iodine. So these are the exceptions that you need to notice. Oxidizing power: most oxidizing, strongest oxidizing is fluorine. You can see its inert values also. Standard reduction potential values, if you see, fluorine is with the maximum positive value. So the strongest, what you can say, oxidizing agent. Oxidizing power: fluorine, chlorine, bromine, iodine. And while explaining this oxidizing power, there is a point that is to be noted. What is it? Um, yes, fluorine electron affinity is less than chlorine, but chlorine, even though electron affinity is more, not a strong oxidizing agent like fluorine. So what are the factors? First factor is fluorine bond dissociation enthalpy is less, so it can easily break, where chlorine bond dissociation enthalpy is more, so it is not easy to break. First part. Electron affinity point, definitely chlorine is having edge, chlorine is better than fluorine. One more point is hydration enthalpies. When you are dropping the fluoride in water, fluoride gives lot of energy. So when you consider all these points, actually there are 5 points: solid to liquid, liquid to gas. But these two stages are not applicable for fluorine and chlorine because already they are gases. Correct? Yeah. Dissociation enthalpy, that energy we are giving. Our favorable conditions means always we should lose less energy, we should get more energy. If we are getting something, it should be more. If we have to give something, that should be less. Right? So in case of dissociation enthalpy, that is endothermic. Endothermic means we are giving means that should be less. And that is with fluorine. So advantage for fluorine. Advantage. When you watch tennis matches, no? 15, 30, 40, right? Then if both scores are 40, then deuce. When deuce is there, advantage. Okay, I get advantage. So advantage is for fluorine here. Then electron affinity, obviously electron affinity is more for fluorine, so advantage is for fluorine. Then hydration enthalpy, that is more for fluorine. So you take all these, fluorine is the strongest oxidizing agent, and fluorine can oxidize chlorides to chlorine, bromides to bromine, iodides to iodine. Then chlorine. Chlorine can oxidize bromides to bromine, iodides to iodine. Then bromides. Bromine. Bromine can oxidize iodide to iodine. Then iodine. Iodine cannot. Iodine cannot oxidize. So simply you can say the top halogen can, okay, now fluorine, chlorine, bromine, iodine. Top halogen can displace all this. Next, displace. And bottom halogen cannot top. That means chlorine cannot displace fluorides. Fluorine can displace chlorides. Oxidizing power, very, very important. Coming to oxidation states. Fluorine shows -1 oxidation state, but +1 in HOF according to NCRT. This is not, um, may not be some, may not be very good point, may not be correct every time. Because fluorine being more electronegative, +1 oxidation state, but in NCRT it is mentioned like hypofluorous acid. So we need to accept sometimes. Then -1 +1, right? Coming to chlorine, bromine, iodine, they can exhibit -1 +1 in the ground state, +3 in the first excited state, +5 in the second excited state, +7 in the third excited state. In general, it contains only one unpaired electron, but when you go for excitation, two unpaired electrons. That means two extra unpaired electrons will come. Already one is there. So total three unpaired electrons. One electron from p orbital jumping into d orbital. Like that, when you are going for up to third excited stage, so total 7 number of unpaired electrons are possible. When 7 unpaired electrons are there, it can show +7 oxidation state. Chlorine can show even +4, +6 also. ClO2. Okay, chlorine dioxide, ClO2, and Cl2O6. In these kind of states, you can expect even +4 and +6 oxidation states also. Coming to any doubts you ask me. Hmm. Next, fluorine is available in the form of CaF2, fluorospar. Ca3PO4 taken twice, 3 moles. 3Ca3PO4 taken twice in CaF2. That is called fluorapatite. Na3ALF6, cryolite. Chlorine is available in the form of carnalite, KCl MgCl2 6H2. These points are mentioned in NCERT, so you need to remember. The similar points we are having in group 16 are like sulfates, berates, BaSO4, all that. Nikita sir, I need previous questions of biomolecules. Sure, better. Actually, I have sent that Akash material. Na? I think in that you will find some around 600 page like that. 28th chapter, I think. 28, 29 chapter. If you are not having, please message me, I will send you. That's around 600-700 pages. All previous JMS questions are there. From biomolecules, around 100 questions are there. Yeah, for your tomorrow's examination, questions definitely will come from previous polymers as well as biomolecules. You must be perfect in that. I will send you, don't worry, just check once. The group is also it is there. If not, I will send you, no worries. Coming to yes, availabilities we are discussing. Elements, other elements combinations. So hydrogen, when you are taking with hydrogen, HF, HCl, HBr, HI. HI is a strong acid. HF is with more bond energy. That's all. No other questions. With oxygen, fluorine can form two fluorides, OF2 and OTF2, but not so stable. In oxygen difluoride, in oxygen monofluoride, OTF2. OTF2 structure will be like open book shape. OF2 bends like water. In OF2, oxygen is with plus 2 state. OTF2, oxygen is with plus 1 state. Oxygen plus, right? So you can remember these examples. Coming to next. Bromine oxides are very less stable. Interesting point. So this is called middle row anomaly. Okay, in oxides of bromine, if you see Br2O, BrO2, BrO3 type of oxides are possible. They are unstable. So immediately what happens is they are ready to lose oxygen. When they are ready to lose oxygen, they are strong oxidizing agents. So bromine oxides are very strong oxidizing agent. Iodine oxides are more stable. Of this I2O5 is used in the estimation of carbon monoxide. Important point. I2O5 is used in the estimation of carbon monoxide. I don't have anything. I'm just recalling all the points I have said. Right? If any line is missing, you don't mind. Just go through it and say that's all. That's all. Right? Then coming to chlorine, chlorine can form Cl2O, ClO2, Cl2O6, Cl2O7. Cl2O is anhydride of hypochlorous acid because when you drop the Cl2O in water, it forms HClO, hypochlorous acid. When you go to the next one, ClO2, oxidation state of chlorine is +4, so it is intermediate of +3 and +5. So when you drop ClO2 in water, it forms HClO2 and HClO3. And when you take Cl2O6 when you drop in water, because chlorine oxidation state is +6, it is going to form HClO3 and HClO4. So when intermediate oxidation state is there, both sets acids are going to form. That is very important point. Then coming to Cl2O7, Cl2O7 is nothing but this is the anhydride of perchloric acid, HClO4. That's all for oxides of chlorine. In that ClO2, ClO2 is a bleaching agent. This point is mentioned. You can remember this. So oxides of iodine are stable, then chlorine, then bromide. Bromides are less stable. This is called middle row anomaly. Clean sweep. Coming to halides. All these they can form. Hello. All these they can form, all these they can form, all these they can form, all these they can form. What they can form? Interhalogen compounds like IF7, CLF5, CLF3, CLF, BRF, BRCL, like these kind of interhalogen compounds are possible. About their structures and all we'll discuss in another session. That is bit away from us. Hydrides, oxides, water, reaction with water. Fluorine decomposes water. Fluorine decomposes water to oxygen. Whereas high beta, high. Um, right? If you have any doubts, you please post here. I don't have mobile right now. My son is doing some work there. No problem. Just message here. Some lines I will explain about that. So coming to what we are talking. Yes, reaction with water. Chlorine can react slowly with water, and it can form HCl and HCl. Bromine also same thing you can expect, but not so easily. We can say they dissolve in water, but fluorine decomposes water. See, fluorine decomposes water. Chlorine, bromine dissolve in water. Iodine, reverse reaction is possible. That means iodine with water O2 is not possible, but O2 can convert I minus into I2. Oxygen can convert I minus iodide into I2. I minus minus 1, I2 0, so that is oxidation. So oxygen can oxidize iodide to I2. I Vijay, Vijay means Trividya Vijay only na? Otherwise I have one more Vijay. Okay na, G Vijay. Vijay చెప్పనా. సో ఈ పాయింట్ వచ్చేస్తే ఏం మాట్లాడుతున్నాం మనం ఇప్పుడు థింగ్స్ అయిపోయింది. HCl and HOCl form అయితే HOCl is unstable, turns immediately into HCl and nascent oxygen is going to be released. One another point. That's it for the normal compounds and all that you can say. Coming to chlorine. How chlorine is prepared? Chlorine is prepared by Dacon's process, HCl oxidation by O2, and you'll be getting the chlorine in the presence of CuCl2. CuCl2 is used as catalyst, oxidation of HCl into Cl2. Otherwise, you can go from Nelson's cell process. What is Nelson's cell process? Brine solution, sodium chloride aqueous solution, when it is electrolyzed. First year, Trividya Vijay, hi da Vijay, hi. Naughty Vijay అని చెప్పాలి. ఓకే, కెమికల్ ఈక్విలిబ్రియం ప్రాబ్లమ్స్ చేస్తున్నావా లేకపోతే స్టాయికియోమెట్రీ చేస్తున్నావా? Hope you are doing right. సో మనం మాట్లాడుతున్న పాయింట్ వచ్చేసి ఇప్పుడే కాలేజ్ నుంచి వచ్చినా సార్. ఇప్పుడు టైం అయితే అయింది బేట, 8 అయింది. ఇవన్నీ స్టడీ అయ్యారా? ఓకే సారీ. ఓ మీ క్లాస్ ఉండింది కదా, ఎక్స్ట్రా క్లాస్ ఉండింది కదా 7 వరకు. యా ఐ కెన్ అండర్స్టాండ్. I can recall. No worries. Today you take rest. మనం ఏం మాట్లాడుతున్నాం? Yes, chlorine preparation. Nelson cell process. First year లో we were discussing this line in preparation of hydrogen, in the preparation of sodium hydroxide, and in the preparation of chlorine acid. NaCl plus water is called brine solution. When you are electrolyzing this, you will be getting sodium hydroxide in the solution, chlorine at anode, hydrogen at cathode. Fine. Next, coming to somebody is coming. Okay. So మనం ఏం మాట్లాడుతున్నాం బేట? క్లోరిన్ కదా, రైట్. క్లోరిన్ ప్రిపేర్ చేయాలంటే ఇంకా బెస్ట్ మెథడ్ ఏంటంటే KMnO4. When KMnO4 reacts with HCl, KMnO4 oxidizes Cl minus to Cl2, and this HCl oxidizes, reduces that MnO4 minus, that is Mn plus 7 to Mn plus 2. HCl is acid, no? So that way. This is the reason why we don't use HCl when we need some acidic medium in presence of KMnO4. If you are using KMnO4 and if you want some acid, we don't use their HCl because KMnO4 oxidizes HCl also to Cl2. That is the problem. That's why we use the sulfuric acid because in sulfuric acid, sulfur is in the highest state. No one can oxidize sulfur from +6 to somewhere else. That is the highest state. Coming to other things, MnO2. When MnO2 is treated with HCl, you will be getting their chlorine gas. If HCl is not readily available, take sodium chloride plus H2SO4. This point we were discussing in last class. Sulfuric acid is very less volatile and it is readily forms the acids which are more volatile like HCl, like HF and like HNO3 from their salts. NaCl plus H2SO4 you will be getting the HCl. Same thing you can use here for the preparation of chlorine. So coming to the chlorine, chlorine is a greenish yellow gas. That's good. Chlorine can participate in some addition reactions with SO2 plus Cl2, SO2 Cl2, CO plus Cl2, CO Cl2. This kind of reactions you can expect. And most important one is, what is the most important one? Sodium hydroxide reaction. If you are taking cold and dilute, hello newcomer, cold and dilute if you are taking, cold and dilute if you take, cold and dilute if you take sodium hydroxide, cold and dilute, it forms NaCl and NaOCl. This is a disproportionation reaction where chlorine changes from 0 to -1 and +1. Coming to hot concentrated sodium hydroxide, if you use hot and concentrated sodium hydroxide, if you use, you'll be getting the sodium chloride and sodium chlorate, NaCl and NaClO3, where the oxidation state of chlorine is -1 in one compound, +5 in another compound. So disproportionation. With calcium hydroxide, chlorine can react and forms bleaching powder, CaOCl2. Calcium oxychloride, bleaching powder, where chlorine oxidation states are -1, +1, average 0. Bleaching powder, chlorine, oxidation states -1, +1, overall 0. Coming to chlorine. Chlorine we are discussing organic reactions. With methane, chlorine sunlight, methyl chloride, free radical substitution reaction. Chlorine, when reacts with the alkenes type of things, chlorine will be simply added. That's all. Chlorine with metals it can react, with non-metals it can react. So many reactions are there. But these what I was saying are important. You can just go with them. When it comes to first year batch, I was talking to them chemical equilibrium and I take 5 minutes more. If any student is coming, it's okay. Otherwise, we'll just keep this video available for the students. Lee Shortlier Brown principle, chemical equilibrium point we were discussing. Very, very simple. I don't take much time here. When the concentration of reactants increases, forward reaction takes place. When the concentration of products increases, backward reaction takes place. Increase in the concentration of reactants forward, increase in the concentration of products backward. Now think reverse. Decrease in the concentration of the reactants backward, decrease in the concentration of the products forward. Okay. Increase in the concentration of reactants forward, increase in the concentration of products backward, decrease in the concentration of the reactants backward. And sir, what are the most important basics along with the important topics that you think that very important? Okay, definitely we'll discuss. Just give me 2 minutes of time. Then after this, temperature. High temperature favors endothermic, low temperature favors exothermic. Simple. High temperature endothermic, low temperature exothermic. Pressure. Increase in pressure favors less volume. Sir. High pressure, less volume. Pressure is inversely proportional to volume. Boils down. When pressure increases, volume decreases. If you have more number of moles product side and if you want to get more products, that means more volumes. So pressure should be obviously less. Less pressure, more volume. Then catalyst has no effect on equilibrium. It just helps equilibrium to attain quickly. The most important point is addition of inert gas at constant volume. At constant volume, there is no effect. Sure, sir. Please do take your time. I will be here. If you want to tell tomorrow, okay, no problem, no problem. Just I'm going to complete in a couple of minutes. You just post all your doubts. We'll be talking, and I will clear all your doubts. No worries. So, addition of inert gas at constant volume. Addition of inert gas at constant volume, how effective. But addition of inert gas at constant pressure. Here the magic comes. You see. Let us say, yes, I'll take my sunbat. Yes. Now you see. Let us say this is the container. Okay, in this container, some reactant products, everything is there. This is maintaining equilibrium. Equilibrium. Yes. Equilibrium maintaining. No. Equilibrium maintaining. Right. So what actually happens is this is at constant pressure. For example, it is creating some pressure of 1 atm like that. You have introduced some gas from here, helium gas or something. This is a closed container. Consider this is a closed container. Into this, when helium gas is coming or neon gas is coming, some noble gas is coming, some inert gas is coming. When this gas comes, it won't react with any other components here. It will be just creating some pressure. It attacks on the walls of the container, and when it is attacking the walls of the container, definitely pressure is going to increase. When pressure increases, what happens? Pressure increases, that's all. But what is our condition? Pressure should not increase because we want to maintain the condition of what? What condition? Right? Constant pressure. But what's happening here? Continuously pressure is increasing. In order to maintain the pressure constant, we increase the volume. Simple. In order to maintain the pressure constant, we increase the volume meter. When volume is increased, pressure will automatically be same. Okay, now whatever the pressure increase was there, accordingly we are increasing the volume. But the thing is, when the volume increases, concentration of every substance comes down because concentration is equal to number of moles by volume. When volume is increasing, concentration decreases. Concentration of reactants decreases. Concentration of products decreases. Concentration of everything decreases. Then what? If me, myself, Lakshma Reddy and Ambani sir, okay, if both we are going to pay the tax, who is going to pay the tax? If both we are going to pay 30% tax, who is going to pay the more tax? If I pay the tax, with that, okay, now, maximum to maximum, my colony road may be cleaned a day. But with the money what Ambani sir is going to pay, with that amount, one village can be reconstructed. Okay. So who is losing more? Actually, he is losing 30% only. I am losing 30% only, but he earned more. That's why he is losing more. So here also, where more number of moles are there, there more loss will be there, more decrease will be there. And now, as more decrease is there, we say, chalo yaar, le lo thoda. We support that side. That means when you are adding inert gas at constant pressure, in order to maintain the pressure constant, we are increasing the volume after addition of inert gas. We are increasing the volume. So concentration of every substance comes down. Then more number of moles side, more decrease will be there. So reaction favors that side. In single line, if you want to say in single line, when you are adding inert gas at constant pressure, the reaction will be favored more number of mole sites. More number of mole sites. This is what I wanted to mention in the class today. That is for junior inter students, class 11 students, chemical equilibrium. Okay. Then you can talk to me, no problem. I'm just in an online class. And what another topic is some numericals we were doing, some good quality numericals. I will try to upload all the numericals. Whenever you have some time, you can just check, go through. Then coming to the important points, important exam, important chapters for JEE mains as well as NEET, as you are asking, right? So first, if you are a class 11 student, organic and physical, all chapters of physical. Atomic structure, one question will come definitely. Chemical equilibrium, ionic equilibrium, thermodynamics, stoichiometry is the heart of the chemistry. You have to. Then organic chemistry, basics of organic chemistry, nomenclature isomerism, GOC, and hydrocarbons. First year part. Groups you can very comfortably leave, but chemical bonding period table don't. Okay, these are the important chapters. Atomic structure, stoichiometry, some basic concepts of chemistry you can see. Equilibrium, thermodynamics. States of matter now it is not there, don't worry. Organic chemistry, hydrocarbons and GOC. And chemical bonding period table. You have to be very perfect. And check all the previous questions also. Coming to the next, the second year part. Kinetics, electrochemistry, solutions. Very, very important three physical chemistry chapters. Carbonyl compounds, alcohol phenol ethers, amines. Again, alkyl halides, of course, important. But the thing is, they are all interrelated. So, very comfortably you can do. Another point is biomolecules. One question definitely will come in all entrance examination except IIT advance. Advance also you can expect, but in general, mains and all we can expect one question. And in that, remember, try to read the questions from NCRT practical manual also, lab manual. Okay. Coordination chemistry is one important one in organic chemistry point of view. If you are good at all this, D block and F block, if you are good at all this, you can very comfortably score 60 to 70 marks. Very comfortably, I am saying, and more than that is also possible. And out of 25 questions, 15 questions will be definitely easy bit tough. Don't think that all questions are going to be tough. Maximum 5 questions will be tough, 5 will be moderate, and 15 questions will be easy questions only. And all these 15 questions you have already answered somewhere in first year or second year in your preparation. Done then. Chalo then. Have a wonderful time. Namaste for today. Meet you tomorrow if possible.